This is Tintri Analytics. So just distinction, everything we talked about was to date was all the happenings on-prem. And this stuff lives in the cloud. So everything you've heard up till now had no cloud involvement whatsoever. And now this is cloud using those metrics from all the on-prem workloads and stuff. Now, when I go into, I'm just going to go into, this is for customers, this is analytics.tintri.com. This is included for quote unquote free for all of our customers. The reason for the air quotes is that it requires an active support subscription. So as long as they've got support on their appliances, this is included. So when they're sending those auto supports, this is our way to give back so that they'll be encouraged to keep giving us auto supports because we use them to make a better product and to make sure that they're good. Now, we use that twofold. One is on the support side for, just break fix, hey, failed drive, send them a drive, meet those 4-hour turnarounds, right? And we leverage that. And then this is what they can use more for planning. So anything that we've shown from a metrics perspective has been 1 week history or 1 month history in Global Center. And this product is intended for a higher level view of the world. So I'm not sure if we have any gamers out there. If you've ever played StarCraft or Warcraft, right? There's some that play different ways. And some people will send their troops over and just kind of set it and forget it. And those troops battle and they just kind of come in later and see what's going on. And others micromanage and like every single attack from every troop, they're targeting which one to hit. And so what we're trying to do is give this sort of overlay so that those VM stores are those little troops on the ground that are autonomously fighting the battles and saving the day. And then this is that overview control plane that makes it easy to manage very large environments that have tens of VM stores, maybe hundreds of VM stores, and tens of thousands or hundreds of thousands of VMs. So this is the sort of the dashboard that you land on that will give a state of what happened last night. The granularity on here is 1 day in our graphs. And if I look at those, actually, I'll go to the trends in just a sec. Quick overview, though, of the infrastructure. We've got sort of the storage happenings, sort of average about the different VMs in there. Of the 6,500 VMs, the average one is this space size, whatever, just some findings. And these are applications, and I'll show this section. This is things that we can put together to create. Now, if we're going into our trends, we have sort of 2 sets of trends. We have trends that are the VMs, the managed objects, the databases, and soon the containers. And these are the ones that have a life of their own and they trend. And then we have a trend of the infrastructure, the hardware itself. So the VM stores, and we have the hosts, like whether the VMware hosts or Hyper-V hosts. And so for right now, I'm just going to go to the infrastructure trends. And we've got a 3-year view here, and I'll just go back. Now, any customer that has not enabled this is an opt-in to enable it, but has been sending those auto supports can enable that and get access. And we'll have all that history, even though they just turned it on now, as long as their boxes have been sending it in. And across the 11 VM stores in the environment, this is sort of the behavior. This was a lull period where this particular environment I'm in, the tech marketing environment, was shut down for a while, relocated, and sort of our hands were full with other things before we brought this thing back up and started doing things with it. And if we find anything interesting, just like in our product, we can click in and see. So we've got this orange and purple and cyan colored to represent our space, performance, and working set. Now, even though this granularity here is only 1 day, we've done a lot of intelligence to be able to represent, like, how do you represent performance in 1 day? Clearly, you can't take all the IOs and divide by 24 hours worth of seconds to give some meaningless average. So what we've done is we've come up with this concept of a peak busy hour. So we have those 10-minute averages, and every 10 minutes, what we've done is we've taken a consecutive set of them so from like midnight till 1 o'clock, that'd be 6 different points on it for 1 hour. And we average that. And then we'll shift it by 10 minutes. We'll go from 12:10 to 1:10, and we'll shift that. And we'll figure out those averages, and we'll find the single highest average peak busy hour. And we'll do this to represent each VM store and every single VM of the 1.4 million in the environment. We're doing this bit shifting and figuring this out to represent it here out of an Elasticsearch database. So here, performance, we had a bit of a spike here. I can click in and see. Now, this kind of looks meaningless if you're not used to what you're looking at. I look at these all the time, so I'm going to drive into this side, and then there's going to be something down in here. But what this is a distribution graph of everything. And we've defaulted to, so up here along the y-axis, the count. So pretty much all of our VMs are like 1,600 VMs live in this range of 0 to 790 performance units, or I could go with IOPS or throughput if those are more familiar than like this IO performance metric. And then inside of that, these are all the particular VMs that are represented. Now, if I were to change this to a logarithmic view, I'll get some more interesting data. And by changing linear logarithmic across the two axes, I can really go in and discover a lot about an environment. So what I can find here is like sort of the true median, the sweet spot of where things live. But most of the time, it's this far right section that I'm concerned with. These are the outliers, right? The single highest performing VM of that day was called RG Tingle 01. Now, this is a data set of 1,700 managed objects, so VMs and databases, on May 30th. And the reason we're on May 30th is because that's where I clicked on the graph. And there's 11 VM stores involved. Now, I could say, no, I don't want all of them. I just want the ones with EC60 series. I'm like, okay, I'll just include those two. And quickly, here's a state of the union with those particular ones and the VMs that are in it. Now, this is very enlightening for customers that aren't used to this and don't have this. This is now, me as a stranger in a customer's environment, I like to do these sessions I refer to as my Sherlock sessions. So I play Sherlock Holmes in their environment, and very quickly, walking them through, we'll tell them, when they click through on the top right here and they see these outliers, I know exactly which one that is. That's the one that so-and-so complains about, or this or that. This always, and it never fails that the stuff that's biggest, hardest to manage, and important bubbles up to the top and is really easy to find. But sometimes things get lost in the averages. In fact, almost all the time. And my favorite analogy, therefore, the flaw of averages is if you take Bill Gates, or I guess maybe Elon Musk, and throw him into a tent full of homeless guys. On average, you got a tent full of billionaires. Like, we know that's inside that tent, that's not what's going on, but on average, that's true. So what we can do is, instead of looking at these all the VMs and all the databases, is we can go in and we can manage our applications to say, hey, I want to group them together. They got properties that they have in common with one another. And when we go into that, we go into our manage our applications, and we have a list here. Now, this is here's one that was called infrastructure VMs. And I still have that filter on VM stores. So let me just get rid of that and get rid of this filter. And this is probably an old group that really doesn't show me anything anymore. I could look for when it was relevant, but right now it's all at 0. Jumpboxes should not be zeros. There's 7 in there. I can click and see which ones they are. RG admin is the box that I'm actively on demoing from right now. And so these jump boxes were all in there. And if we wanted to see how this group was created, this definition said, hey, the path in the object manager, so in vCenter, anything that lives in the vCenter defined folder called jump boxes included in here. So this is dynamic. This changes all the time, live, real time. and goes back historically as well. So I can create new groups really simply and track the things I care about. So for things like VDI and stuff, this is really useful, really important. Now, the thing is that we've got these seven VMs that were represented in Jumpboxes. And now I want to see historically what they look like from a performance standpoint. So if I look at IO performance here, I've got a graph. The purple are the IO performance. We have filtered automatically down the application. That's just this Jumpboxes. And we're going back, looking at our 3 years. And then this blue that you're looking at is a field that I had us add to this to show by default, because it tells a lot, usually in a lot of cases. And this is the number of objects that are being represented.
Rob, you mentioned performance units before, but I don't think we ever asked you actually to define what they are.
Sure. So the closest thing we have to representing them in our products is what we show through a normalized IOP. A normalized IOP is normalized to 8K. So it's sort of IOPS on their own are kind of meaningless. I like to think of them as RPMs in a car. And I told you yesterday, hey, I was going at 5,000 RPMs yesterday. Was I going fast? Yes or no? Was I on a highway? Was I on a side street? 5,000 RPMs does not tell you anything. If you knew that I was in sixth gear, oh, okay, what model car? Then it's kind of more meaningful. So bringing it back to this IO performance, this is a representation of a number of performance units that we use inside of our, to create those performance reserves that if you had high IOPS or high throughput, it would mix. So a lot of times if you have a large block size, you'll get a very large throughput number. The IOPS might be pretty small. So if I told you it was 2,000 IOPS, you might say, well, that's not much at all. I'm like, yeah, I didn't tell you the block size was 1 gigabyte. Whoa, okay, that's huge, right? But, in most cases, you're looking at 8K or, 256K block size. In order to make it apples to apples, we brought it down to these IO performance units. So if there's a spike, this would show the spike across the two other variants, which would be your IOPS and your throughput.
Okay.
Right. So if you were looking at IOPS exclusively, you would not see those spikes that were high throughput if the block size was small. If you were looking at just throughput, you might be blinded by only seeing 1,000 megabytes per second, but not knowing those are 4K blocks going through. This sort of brings that apples to apples into the whole thing.
So can I ask Rob, actually, just as an add-on to what Ray's asked there, are you taking, to apply context to what's on screen here, are you taking telemetry from all of your Tintri customers to try and average this out? So a customer could look at it and say, how am I performing in respect to somebody with a similar setup?
Yes and no. This is specific to the data here, right? But we've taken the data here to do what you're talking about. And I will show that in the planner. So why don't I move to the planner right now? So the planner now lets us take the VMs that we care about. In this case, it's these Jumpbox VMs. Going to add another member to the tech marketing team, right? Is their Jumpbox going to break the bank in terms of the infrastructure that we have available? So when I go over to my planner tool, this is all 11 VM stores in this particular environment. This is from right now, today, so just January 20th, looking into the future, and the default is 18 months, but I can drive this and go even further if I wanted to into, let's just say 2 years to January 2023. So we can do this up to 5 years into the future. And this, I'll set this to 2 years. Looking forward now, the environment that I'm in is kind of boring because there's no organic growth. It's flat right now. And if I were in a customer environment, it would not look this way. It would look trended nicely. And I can go into our DevOps environment, a different one that will have some different trends appropriately. And so what I want to do is in the future, so in February, we make our hire. And we're going to, and we can choose events here. And we're going to either add and remove a VM store. So let's say that we are consolidating the environment. We could say remove and I can remove the various VM stores, and I'll say, you know what, let's get rid of this hybrid. We don't want to use it anymore. And let's go here and do another remove event. And we will remove the 540 from the environment, another hybrid. And I could keep doing this. And what you would find is that now what we're left with, our usage of other patterns is going up. Now, just to kind of drive home, if I do that same thing and remove one of the bigger units in the environment, everything will get a lot closer to 100% here. So we'll do another remove action, and I'm going to remove a, let's say the 6090. Okay, and so this is what's kind of left over. Now we're going to do our action of adding, and I want to deploy new VMs here. And so the new VMs I want to deploy are of type, and so we'll default to the average VM in the environment. But I don't want the average VM, I want a jump box, right? So one of those jump box VMs. Now again, from the noise of everything, these are all the patterns that are going to fit. Now these things aren't big enough to break the bank, just one. So let me just add 200 of them. And at 200, we're really not even doing any kind of special trending, but we're consuming more space.
In this case, can you also import a list, for example, RBTools export or some kind of sizer analysis data from environments, existing environments?
We've got an oracle in the house. Tomer, you want to field that?
Yes. So we're actually working on something similar with RBTools, but I think we have something better, because what Rob is showing is planning based on workloads that you already have in the environment, right? So if you have a jump box, you define the application like Rob was saying, then you say, oh, what happens if I deploy 20 more of those, right? But if you want to plan for something, for an application that you not yet have running in the environment, then we have this these set of profiles that are based on common applications across our installed base. So similar to the mapping that Rob was just doing, right? We have a large number of customers doing that for a large number of objects. So we can profile VDI, we can profile a database, Oracle database, SQL database, all those objects, and that's where we have this deploy common VMs option, where Rob is just highlighting that.
Yeah, so I wanted to come back to Paul's question and statement earlier. Are you doing anything to leverage the intelligence of your entire install base? And the answer in this case is yes. And when I choose this deploy common VMs, and I look at what's available in here, one of the things in here is virtual desktops from financial firms. And we've got virtual desktops from healthcare firms. So if we said virtual desktops from healthcare firms, this is taking real world data from the fleet that's out there for all customers that are related to healthcare. And we're going to add, say, 500 of those. We have how that may impact the environment that's left over here. Now, to look at what makes that up, I'm just going to go into edit, because you might say, no, that's too conservative. My environment is more than that. And I just want to show you what's going on behind the scenes in being able to model this, because on the surface, it seems pretty trivial. Like, I think we've made it look quite simple that, hey, you're just adding something to it and adding on. But what we're actually doing is we've defined of all the VMs that meet a certain criteria, that they have a particular size associated with them, a particular I/O performance, and a certain growth to them. And in this case, these are not growing; they're static. But we could say, no, I expect them to kind of grow a little bit. There's some working set growth on them, but just measured in bytes per day, so very, very minuscule. And logical space growth per is also very minuscule, and we could alter that to make it higher if we wanted. And then we're taking the data itself. Now, this part I find fascinating, because we know which blocks belong to which VMs, we're able to show exact space savings factors for every file on there. So how much compression and dedupe you get really depends on which model you're going to buy. And when you're buying all flash storage, you typically see some sticker on there that is your effective size, and it's typically industry average 5x. So if you went to the Tintri spec sheet to look at our VM store models, you'd find that on our VM stores, we'll use a 5x number as well. And you may not get that. You're like, oh, I'm only going to get 2x or 3x. We know exactly what they get. And these two numbers represent after compression, but with or without dedupe. So if you modeled it onto a hybrid, we'd use this number. And so now, instead of knowing that this model gets 5x, for these types of VMs on it, we give them a 2.93x space savings factor. And so if your space is being consumed, it's not about the biggest VM on it. It's about the biggest VM that's using the most physical space relative to the rest of the box. And so we have that knowledge and insight. And that's an area where no one else has that level of insight. No other flash manufacturer out there is breaking down space savings factor down to the per vdisk and per VM level. And this we have in our product today, and we use it for modeling. So I can apply this, and now that I've added a bit of growth to it, we will see that the performance trends kind of upwards.
So, Rob, just to close on Andrea's question, right? So adding data from other sources like RV tools won't have that depth, right? And that's where we're trying to use our source, because the data is hosted on the Tintri systems, and then we have a lot more matrix to build on.
Now, if you were to dump RV tools daily, we would be able to trend something with that for some of the metrics, not all of them, but overall size or something we might be able to. But the RV tools doesn't capture anything around performance. So you'd need to do some dumps from vCenter or something around performance. And then you'd need to figure out how to model, like roll those all up to make a unit that makes sense. You couldn't just take the number of hertz in a day and then divide by seconds in a day and just, give us some useless average that way.
So you're building profiles based on the global customer base that build the average XYZ server. And based on those metrics, you're creating a set of profiles, correct?
Twofold, yes, correct. So that is one. That is the deploy Common VM. Those are created by Tintri from Tintri customer data. And then the other were deploy was just deploying a new managed object, and these would be derived from what the customer has in their environment, and they create their own application groups. Sure.
What other kinds of analytics are you compiling to create these models? IO is a very valid and important detail, but it's not the only detail.
Right.
I would also say that what data are you not collecting deliberately besides, the obvious, the personally identifiable information or customer usage information?
So we are collecting the metadata about the objects that reside in the system and all the telemetry associated with them. Anything that is inside that file system in that VM, we're not cracking it open and scouring that. We don't know what's inside. It's just a vdisk. We assume it's the C drive because they have it mounted SCSI 00, right?
So what if it's a VM based on who knows an HPE laptop for the image for VDI, and the next customer who wants to use that as a model is running Lenovo, and the usage specifics or details are slightly different there. Obviously, Tintri is able to modify performance after the fact, but when you're looking at deploying a VDI infrastructure of 15,000 instances, those one or two little metrics really make a difference.
The devil's in the details, right? Absolutely makes a huge difference. Just like, so one of the things what we can't figure out, and to my knowledge, nobody can, is the true demand of an application unless it is met with an unlimited amount of resources. That said, an application adjusts itself to the constraints of what it's run inside of. So if it had no performance bottlenecks at all, we would know its true demand, right? As soon as it hits some latency, then it starts to queue, it goes to queue depths, and then things kind of change, right? So we don't know if it started to queue because it was 90% of what it wants, or if it was only 10% of what it wants. And we know that clearing a queue is very expensive. So there's a lot of hidden details in there that we don't know at this time because ceilings may have been hit of say hitting latency, that we don't know what the true demand would be had that latency not been hit. Is that kind of in line with what you were saying, sort of modeling the two? They're slightly different. What we can see though is that in a customer environment, and I've gone through this a lot, where they are here looking at, let me just back out to the trends for a second. And they're you know what, I'm going to use a different environment that is just internal here.
So Rob, while Rob is changing screens and stuff, I'm just going to reiterate too is, Rob keeps saying VM. This also applies to SQL Server database. And as we launch other products, i.e. containers or other database manufacturers, they'll apply the same insight to those objects as well. So it's not VM, it's per managed object.
So on those, question for you guys. So on these managed objects that you're tracking, are you taking any of that telemetry data and feeding it into like a training set for a neural network? I'm just trying to get the measurement of where the AI component is coming in. Yeah. So
very much
Jason's
so.
like another.
Yeah. What do you know?
So okay. So this is where I struggle a lot for several reasons. One is I just want to barf it all. Like, here it is. Like, look at it, all of it, and like it's just too much, right? Also, I am like really, really confined with keeping our customers' privacy private, right? It is very, very integral, like that our customers trust that, we treat their data appropriately, right? And we collect the data for their best interests, in their best interests. And I would love more than anything to change any of these to real environments, because the growths are perfect. I mean, these graphs look so beautiful in real environments versus like a lab environment. So by focusing on Tintri internal stuff, I am not showing you what a customer sees, which is better, like, because their data very much follows trends and stuff. Now, I was going to break today into 3 sections of analytics. This analytics.tintri.com tool, what we're doing in it. The second one is this internal only anomaly detection. This is the neural nets. This is finding the really cool stuff, you don't know what you don't know, and people aren't finding it. And this is the most exciting, because I've worked all year on it with a team of data scientists, and we've got the results are kind of mind-boggling on what we found. And we're still wrapping that up to productize it, to bring it out. So when I do show that, and I will shortly, I will move between VM stores that belong to us, Tintri, because I can share that. And then I will show you just screenshots where I've blurred things out that are also interesting data, but I don't want to reveal any customer names. So our biggest, best customers, I would just love more than anything to say their names, but we are one of their best kept secrets. They do not want anyone to know what they're running internally. They get a lot of efficiencies out of it, and that is part of their secret sauce, that they don't want the world to know that that's how they run their operations. So some of these names on that list would really, really shock you, and I can't unfortunately divulge who they are. But that said, this is how we've distilled things down, right? This is the beginnings of it. And then the anomaly detection is where we're taking it next. And the third piece is what we call advisor, which is this little pane on the right here. And this pane on the right will show us high-level information that is useful, actionable, that will make the environment a better place. And it's that advisor one that we're putting a lot of effort to come up with new definitions. let's go to develop environment. So we have 3 environments: develop, QA, and then production. And customers just see the production stuff. The QA is our staging environment, and develop is where stuff happens. And the only reason I didn't go to QA right now is because something is in QA that didn't pass and has to be pushed again. And this stuff's in development right now and is really also in QA and is on the cusp of being live for customers. So we've taken this, the application list that I had before where we define them, and we've overhauled it a little bit. So we've put it into a table format to make it a little easier to see. We've got storage, and there's also compute too. So how many megahertz and stuff like that, RAM that these VMs are consuming, and databases, but no CPU or RAM for databases. So I explicitly left them out, Sean, when I said VMs. And so here we can see a list of things, and we can sort by these fields. And I could look at something like, these object definitions that, on average have the most space per, and I can click into those, and this will just bring it down. Actually, didn't do it right now, which is one of the reasons to develop, and define it to that one application. Let me just hit refresh for a sec, because I'm not sure why it didn't, and it could have been stale. Give this a sec to load.
So this is loading the Tintri develops as the customer, right? So the customer data that we'll see on the screen right now is coming from the Tintri production system.
Customers don't change between. That's, privileged access to switch between. And we go to our applications. And we'll have this list of applications, and we can drill in and figure out, all the VMs that make up these applications. Also, our dev instance that we're running this in doesn't have the same horsepower as the prod. So I usually demo out of the prod for that reason. But we can go in here. We can click on one here, and this will bring us out. And you know what? This piece isn't working in dev. It works in QA. Another piece is broken in QA. There's a reason it's not in prod just yet.
We brought a gremlin to the demo, so we usually bring one along. Sorry about that, but
I'm used to them. It's all right. I could go to the QA right now. I just know that I could get stuck in a rabbit hole. The only thing that I didn't do was change this over to that specific one that I clicked on. It would change it, and you would see them represented here. The reason that I was in development was less about that screen. It just happened to be up when I switched tabs. It was more about the newer things that are in this pane on the right here, this advisor pane. Now, these critical ones are a whole bunch of VM stores that have not reported in a certain amount of time. And these are considered new alerts because nobody has acknowledged them or done anything with them. So I can click on this, and if I look back in time, this guy never made the migration from that October 18th, cut off from that one data center to another. And this is, if it was in there, this is what we think it would be doing based on the data we have. It's sort of sinusoidal in nature, where we know that there's sort of some peaks inside of weeks and inside of months and inside of years. And the weighting of those things change based on the data there. Not having much of a data set here, we haven't done too much with it. When we start to get into the neural nets and stuff, this is where we have a training model per VM store. So it's very expensive to calculate. And we trained it on the last year, and we're representing the last 6 months in this anomaly detector that I want to jump to. That is, let me change to all activity. This
is the training. Just a quick question. Is the training of those instances done on your cloud services?
It's done in AWS across systems out there.
Thank you.
And it's using a modified Facebook Prophet as the algorithm for predictions, and the prediction model had to be tweaked because we have some nuances there that are really specific to us. What we did was we took a lot of the nastiest performing ones that I'd been involved in on cases and stuff, started with those, and then started to refine our models. And we got to a point where now, if it's worth looking at, it bubbles right up to the top. So it's taken us a year, well, over a year in the making, but like just specifically on that portion, probably about 9 months of dedicated work refining that one algorithm to bubble up our priorities in the anomaly detection.
Are you using the GPU instances over at AWS?
I don't know, actually. That team is
those are nice
team working on it. I'm spread so thin. I'd love to know that, but I have my limits. So, back to some of the advice that's showing up here. We have ones here that's saying, hey, we got thick provisioned files. So this is kind of wasting space unnecessarily. We have some reservations on there that we don't want to have. And we got one here that space consumption problem. So we can click in, and these actually, the space consumption, performance consumption, and the predictions, when they're going to alert, they're already in production to show customers that. So that's based on either actual hitting thresholds or the predicted measurements exceeding thresholds in a certain time period. So it really hones in and says, hey, this one's problematic, because when I looked at the whole thing as an aggregate, the space was like at 40% or something. What I didn't see is that some particular VM stores are redlined at 95% and are going to have some consequences if they run out of space. So this bubbles that up quickly. We've got, let me hide those criticals there. And this one here says that it's not it's not redundant state. So the controllers, one of the controllers is down, right? So important to know that, like, hey, operationally, no one knows anything. It's just a data store, all the VMs work, but someone's not paying attention and should be. So we can see when it triggered, if it re-triggered, how often it's triggered, and we can do things like acknowledge it and say, this was resolved by support, or whatever we want to put in here. We have sort of a log of what's been going on. And the thing that
Rob, let me just take a moment and provide some context here, just to kind of recenter everything. So what you've seen so far for everybody on the call is that we've used analysis and optimization and AI at the low level to do all the day-to-day things, making sure that things are speedy, the response times are very good, that from an overall holistic kind of capacity management and optimization standpoint, those are all taken care of. And so the default position for most Tintri customers is that they don't manage what we would traditionally call storage. And so what we're doing here is we're doing deeper analysis on the data that we get so that we can expand that kind of worldview of other things that we can do to make the storage experience even better.
Now, earlier, Matt had asked, is there any data that we're excluding? We have a blind spot for what we call other files. It's the stray file queue. And if you've not registered your particular ecosystem manager, so if you have a vCenter in your environment that you forgot to register, we're not going to discover the VMs on it, yet that space still gets consumed. And those VMs don't benefit from going into those lanes to get the performance isolation. Now, all the other VMs are going to be fine, but those particular VMs are going to suffer because they're all going to share one lane. It's going to feel like a traditional LUN to them. Now, so what we've recently, like this is almost ready to roll to prod, is this unregistered VMs detected. So based on the contents of the file system, all the files left over that have not been identified as managed objects and self-discovered, these are the folder names that we think are the VM names, how big that folder size is, so the size of those VMs, and the number of files inside of each. So for any admin in the environment that has this large spot of unregistered, it goes unnoticed when you have a lot of VMs. But not having it really impacts our ability to help yourself. So this is us now finding those things, bubbling that up, and saying, take a look at this. And somebody who runs the environment would look at this and like, yeah, that's my developers. Like, they all live in this particular vCenter. Why aren't they there? Oh, I forgot to register it on that VM store. As soon as they do that, all of those files get put into these managed objects. They have a principal ID associated with them, and the Tintri magic helps them. And on our dashboard, we have this thing called other. And in a healthy environment, that's zero. There is no other. Everything's been fully identified. So these are some things that we're doing to take the insight and knowledge to see that all the other across all the environments really comes down to a few different use cases. It's a submount that someone created as a new data store and didn't register a vCenter. It's it might be cloud volumes. It sometimes shows up like this, where they have all these layered or Citrix layered apps for VDI and stuff. And so we're really starting to go in deeper here to break this down and say, hey, look at this.
So Rob, while you're switching to, I guess, anomaly detection here, also wanted to make a few points. So I think what you've seen, I mean, obviously we've shown a lot of different capabilities, but for us, the cloud capability started with the ability to aggregate the data, present all those graphs and trends. And in the beginning, we relied on the actual user or the admin that looks at the data to draw conclusions, right? So they had to figure that something is about to break, or they had to digest the data and figure what's going on. And that's where we added the advisor as a framework to provide those insights, right? So we actually detect those things. We detect anomalies or things that are as simple as, controller down, right? So not everything has to be AI, but there is some AI in some of the advice. And the reason for switching between this dev environment and production is because everything is our CI/CD process, right? So this is a cloud application. We push those advice, that content, to production on a regular basis, and we just add those insights. So again, the first phase was to create the data lake, present the data, and now we're drawing conclusions, and we add more and more of that content, really digesting that for the user. So you don't really have to look at the graph to figure what's going on. We just tell you.
Yeah, and let me add to that, Tomer. So again, just to contrast this with, maybe other storage systems that have a different architecture, maybe relying on LUNs as kind of the unit of measurement, they're using all of this cloud horsepower to tease out what we have as source data. So the source data that we have, the VMs, behaviors, the reactions of the appliance, that we already get clean. We don't have to spend any cycles in the cloud trying to tease that information out. And because we get clean, we can stack it day after day, year after year, et cetera, to create these learning models. We train these models over a large amount of time to bring out some of these insights. And so again, if we're to rely on maybe a different model where we rely on LUNs and some correlation for that, you could do all work, you get one data point for one day. You do that for 3 years in a row before you can get the source data set that we come to the market today that you're already looking at in real time.